While the act of cooling air with wetted media has been around for hundreds of years, there have been improvements in how the technology gets implemented. And while the technology is simple, we have engineered a wetted media system that employs 5 patent-pending innovations: temperature control, individual staged dry-out modes, multiple pumps that run only when needed, a power flush drain pump that also provides constant circulation, and our most innovative pending patent of all, cycles of concentration control.
Not something we're patenting, but still worth mentioning. Our wetted media system is very easy to assemble. All you have to do is assemble the frame and hang the media cassettes in the frame. Our design includes slots for precise cassette placement.
The temperature control optimizes uptime and cooling effectiveness. The media must be dried out daily to prevent organisms from growing in the media. When a stage of the system enters dry-out mode, our controller monitors temperature both upstream and downstream of that stage. When these temperatures match, we know the stage is dry, and the controller allows that stage to get back to work. As a result, dry-out times are never longer than necessary, and uptime is maximized. Our wetted media system is able to cool constantly. We accomplish this with individual staged dry-out modes. By building multiple, separately controlled stages into the system, we can dry out one stage while the remaining stage or stages are evaporating water and cooling the air. The third patent we are pursuing is for multiple pumps that run only when needed. Compared to one large pump, having one pump per stage allows us to use smaller pumps that run less frequently and use less energy when they're running. This also provides built-in redundancy. Our power flush drain pump is yet another idea worth patenting. Besides constantly circulating water through the UV germicidal system, this pump keeps debris constantly moving and in suspension before being directed by a jet of water to the drain. And finally, cycles of concentration control. Steve's a chemist. I'll let him explain this one.
Hi, my name is Steve. I want to take the next couple of moments to talk to you about cycles of concentration and how that may provide optimal performance in wetted media systems. First, let's look at what a cycle of concentration is. Think back into your high school chemistry days. If you took a beaker of hard water, you will know that inside that hard water there's solids, scale-forming solids. If you evaporate that water down, those solids do not evaporate, they concentrate. So, for example, if you took the volume of water and evaporated half of it down, the concentration of solids that remains in the half of the volume is twice. So you have a cycle of concentration. Continuing evaporation beyond that, the cycles of concentration increase to 2, 3, and so on. So why is that important to a wetted media system? First, let's say you have a certain quality of water coming to the system and your concentration cycles is too high. What could happen is that over time you form excess scale buildup, potentially affecting airflow through the media, and even potentially over enough time affecting the structural integrity of the media. On the other hand, if the water is too pure and too few cycles of concentration, it could be slightly acidic in nature, a little more aggressive, and soften the media over time. So what you really want to have is a window between a minimum cycle of concentration and a maximum cycle of concentration. Once that's done, that gets put into the software, and the software, understanding the usage of the water, then manages the drain cycles such that those cycles of concentration are maintained for optimal performance in the wetted media system.